The capture zone is the space in front of the hood where the air velocity is sufficient to capture the contaminant cloud. One way to envisage it is as a bubble in front of the hood. Inside the capture zone, almost all the contaminant will be captured. Outside the zone, almost all the contaminant will escape. A flange restricts the movement of air from behind a hood, changing the shape and extending the capture zone in front of the hood. It reduces turbulence in the airflow into the hood, which improves the effectiveness. The shape of the flange is also a factor. A flared inlet is even more effective. However, even with these improvements, the capture hood is still prone to drafts. This bubble is easy to disrupt. It can shrink and change shape. Drafts can seriously affect the size and shape of the capture zones, and powerful drafts virtually destroy them. In this demonstration, we're using smoke to represent the contaminant generated by the process. Begin by moving the smoke source around the hood inlet, gradually moving further away from the opening until the full extent of the capture zone can be observed. The position where the smoke is no longer being drawn into the hood is the boundary of the capture zone for this process. For this demonstration, a yellow wire loop is fixed to the hood to represent the shape of the capture zone for this process. An anemometer is used to measure air velocity at the edge of the capture zone. In this example, the velocity at the edge is around 0.2 meters per second, and this is known as the capture velocity for the process. The velocity at the face of the hood is 3.5 meters per second. Typically, at a distance of 1 hood diameter, the air velocity will be about 1/10 of the velocity at the face of the hood. The capture hood is marked with the effective capture distance for this process. This is almost always smaller than the user expects, and it's due to the fact that the air velocity falls very rapidly as you move away from the face of the capture hood.